Hello everyone, this is Inderpreet Shoker with ARC Advisory Group, and today we are in conversation with Dr. Claus Reimers. Claus is Chief Product and Technology Officer at Akselos. Welcome, Claus.
Hello, Preet. Very nice to meet you.
So Claus, I wanted to start our conversation with a topic that is, end users are talking about all the time, and that is of digital twins. When it comes to the industrial world, what kind of digital twins you think are going to be useful to end users?
That's a really good question. So, and you said already, there's not one digital twin, there's a flavor of them, right? So let me give you a little bit of an overview. So there's the 3D digital twin that has the as-built, as-maintained, as designed replication of the actual asset. So that's used to understand how things look in 3D. You can attach data to it, etc. Then there's something like a process digital twin. So this describes how the process behaves under different loads, different conditions, allows you to debottleneck a process. There may be something like a control digital twin, how you that reacts or lets you test your control strategy, etc. And then there was one thing missing, and that's what we are going after, which is we call it structural twin, structural digital twin. That's focusing on the structural steel of the actual assets and helps operators to widen the operating envelope, avoid unplanned downtime, reduce planned downtime, focus inspection, maintenance, repair where it matters most, and extend asset life.
Yeah, that's great. Very good overview of digital twin technology, Claus. Another thing I wanted to ask you is, whenever we talk to end users, one challenge they always mention is unplanned downtime.
Yeah.
So with your experience, when you talk to end users, have you seen a shift in what they were doing before versus what they're doing now to, address this challenge?
Yeah, let me zoom out a little bit. So I worked at AspenTech for a long time, but there's many of those vendors, right? And we had, like Aviva and others have, a suite of different tools to optimize the process itself. That's pretty advanced by now, and that helps to avoid unplanned downtime. Then you go into your manufacturing execution. You have planning, scaling, MES, APC, etc. You can optimize there to avoid unplanned downtime. But then clients came back and say, look, if stuff breaks, all this optimization goes out of the window. And that was when APM basically was born, right? So asset performance management. And at that time, we actually looked at the asset itself, and we wanted to model the asset in real time. But we couldn't find the right solution, so we focused on rotating equipment. And I think the world is quite advanced there, right? So you have things like Aspen Mtel, Predix, a solution from Aviva, and many others. They're really, really good in predicting this. Then the last part that's left is kind of structural steel, where you see that the industry introduced over the last 30 years or so inspection data management system, risk-based inspection, maintenance optimization, different analytics. But there's still a gap, and that's what we try to close with something we call structural performance management. And we're seeing good traction. But overall, coming back to your question, I think there's a lot of progress been made over the last 20, 30 years.
No, that's great to know from you. Another topic that is of great interest to everybody these days is AI and analytics.
Yeah.
I want to know, in the industry, are you seeing some real use cases of AI? And a lot of time I see the comparison with physics-based model as well. Any thought on that?
Yeah, it's actually interesting. I saw just here at the conference this morning was a talk from PepsiCo. It was kind of like impressive to see what they have rolled out and can do. But there was one thing was really telling. AI is really good to consume a lot of data and make sense out of it and provide. AI is not good at math. And this is kind of like where I see the balance is. So there's a room for physics-based model, since the assets we operate are multi-billion-dollar assets. If something goes south, is really bad, you put humans in danger, you could have toxic releases, etc. So that's where you need the physics and the chemistry to make good decisions. AI is then a tool, even agentic AI, to automate workflows, interrogate this data, etc. We're working on something where we kind of like came up with 4 use cases. We call the first one understand. Instead of looking at dashboards, etc., I type a question like I would do in ChatGPT or Gemini, and the tool interrogates the physics-based model, the data, and answers. The next one is detect. So something gone off the rails, and AI can see that way faster than any human and at a way wider scale. And then if something goes south, or if I want to know something, there's something like analyze, figure out why did that happen. And then the last thing is a predictive angle where you go into optimize, and AI can run those models, right? I don't know if you know about a tool set called MPC. This is where you can match the tools and the agents. So it calls via MPC the tool set, and it gives the answer. So that's, I think, where I can provide a lot of value, and I've seen that rolled out of scale quite a bit, yeah.
Yeah, very exciting times we live in. Another thing I wanted to ask you is, when you talk to end users that have to manage complex assets, huge assets, what are the challenges you think they're going to face in the next few years or even this year?
There's multiple things going on, right? So in our industry, we see aging assets.
Yeah.
So the question then comes, especially when you also look at energy transition, et cetera, do I replace this asset? Do I extend it? What do I need to do to fulfill the environmental regulations that come up? Margins are getting tighter. I was at a different conference in Cannes earlier this year. There was somebody from Salomon that basically showed a very interesting chart on the margin pressure, and she had a red line and say, if you're on the left side for the red line, you're going to survive. On the red side, not. So I think it's pretty much getting more out of the asset that you have with minimal OPEX and CAPEX. I think that's what it is.
Claus, another thing I wanted to talk about is structural integrity, since you guys are an expert in that. So typically, end users, when it comes to structural integrity, they manage it, periodically, doing inspections, periodic risk assessment and so. So what is the value proposition doing it continuously rather than periodically?
Yeah. Really good point. So what people normally do is like you said, they're very real time when it comes to the process, and then periodically when it comes to the integrity part. And there's a lot of opportunity left on the table. So let me explain. Let's take a coker as an example. So what you do is you operate this coker for 4 or 5 years, and there's different shifts, 24/7, very cyclic process. And then the integrity team does an inspection, and they open it up, and they're going to find certain damage that's normal to happen. But what they get is a snapshot from here and 5 years, and they don't know how this damage happened, so they can't make it any better. If you do this continuously, like for example with structural performance management, you see exactly what happens in the steel while you're doing it. Shell calls it, you let the steel speak. And when I know that, I'm going to find for that type of equipment, for example, that 2% of the cycles create all the damage. But I don't know that, since I just get this cumulative picture. In a second I know that, I can go back to my data historian and see what were the process conditions that actually drove that damage, and can optimize that. And in addition to this, it's quite common that you can also then shorten the cycle time. That gives you more throughput. The same is true for furnaces, for steam masonry formers, etc. So like you measure temperature, pressure, and flow, and you see this on your control panel in the control room, you can see what the structure does while you're operating it, and that allows you to widen the operating envelope, spot things early before they come back, optimize inspection, maintenance, repair. And the other thing, kind of like as an added benefit, we talked about are the late life challenge that we have in our industry. I can extend asset life at the same time. That's a benefit.
That is great, Claus. Another thing I wanted to learn from you is that I know you have said in the past that structural intelligence is kind of the glue between process optimization and integrity management. And historically, we never hear that kind of conversation. So why do you think this is important now and we didn't see this before?
I think it's a technology topic. So when you do process simulation, etc., that's common, that's there since 30, 40 years or whatever. And structure, like you just said, is periodic. The reason for that is if you want to do a full detailed structural analysis, it's very heavy. Normally tools like FEA are used for that. Those tools are extremely precise, right? Planes are designed by this, car are designed by the assets in our industry. But it's not fast, it's not used in operations. So what's behind, for example, the Akselos offering is that we can run the exact same simulations, but 1,000 times faster. So now I can deploy that technology that's very well proven in operations. And depending on how I operate my plant, I get a structural response. When you go to your RTO, when you go to your advanced process control, You have an operating envelope, and that's limited by process constraints and structural constraints. And what you see in 80% of the cases is that the optimizer gets stuck in a corner between these constraints. The process constraint is super well understood and may get updated. The structural one, never. What that technology does, it basically allows you to update the structural constraint, and then your optimizer are just going to push against it. And that's what we call the glue. So you get a real 360-degree view of your plant, from a process, a control, a manufacturing supply chain, and the structural part.
Well, thank you so much, Claus. I learned a lot. I absolutely enjoyed our conversation.
Thank you. Same here. Thanks for having me.
So we were in conversation with Claus Reimers. He's the Chief Product and Technology Officer at Akselos. Thank you so much for watching.